Hello, everybody. Welcome to my presentation. In this chapter, we will discuss how to establish a network based on a switch, and we will discuss how the switch is worked in a network. And as we know, nowadays the LAN, the network of the local area, is mostly built on the Ethernet, on the technology of Ethernet. And the Ethernet, we know, we can implement it by different technologies, by different physical medias. Okay, the most simple, most originally, we use the coaxial cable, just one line, no device. And then all the host is connected to this cable using the NIC, using the network interface card. And as we know, only one device can send data at one time. If more than one device is sending data at the same time, then the collision happen. Okay, so we need to use the CSMA CD mechanism to avoid the collision. Okay, and after that, we introduced a device we called hub. The hub is worked on the physical layer. Okay, the hub will still sending the signals, just flooding the signals from one interface to all other interfaces. So between the host, the collision still will happen. Okay, but the hub is a centralized device. It's more easy to troubleshooting if the network errors happen. Okay, this is the hub. And then after that, we introduce the switch. The switch is worked on the data link layer. Okay, the switch divides the collision domain based on the interface. The one interface, one switch interface is one collision domain. Okay, so the collision will not happen between hosts that are connected to a switch. Okay, and then the switch still have mechanisms to forwarding the data frame. Where to forwarding the data frame? Have the decision process. Okay. And in this chapter, we will discuss how the switch is worked. And also, we will discuss how to configure an Ethernet switch interface. Okay. Then we just see the topology. This is the most simple network that only contains one switch. Okay. One switch. Construct a LAN. Then there are three hosts connected to the switch. Okay, the interface gigabit 001, gigabit 002, and gigabit 003. Of course, each host have the IP address and the MAC address. As we know, the IP address is the layer 3 address, and the MAC address is the layer 2 address. And as we know, the switch located in one network. So the IP address must be located in one network, okay, in the same network, but have the different host part, okay. The network part is the same. Of course, the physical address, that's a MAC address, it's a burning address burned in the NIC, network interface card of each host. Okay, so they must be different. Okay, then when a host, for example, host A want to send data to host B, host C, okay, then what will happen? As we know, the host A must know who he wants to communicate. So the host C must be told the destination 10.1.1.3, okay, must get this information. And the source IP address and the source MAC address must be this, okay? The source IP address 10.1.1.1, okay? This is in the IP header, okay? But when the data wants to sending out, should encapsulated by the Ethernet frame, okay? In the Ethernet frame, there's another two information, the destination MAC address and the source MAC address. The source MAC address is easy, just the MAC address of its NIC card. But who is the destination MAC address? What is the destination MAC address? And then, first, the host A wants to sending data to host C, but host A did not know the MAC address of host C, so cannot encapsulate the date. And then the switch A also there's a mechanism to decide how to send the date. So the switch A worked at the data link layer. Data link layer we have the MAC address. So switch A will maintain a MAC address table, But initially, this MAC address table is empty. Okay, is empty. And then because the host A did not know what's the destination MAC address of host C, then the host A we are using the ARP process. We have already discussed address resolution process. Okay, address resolution protocol. Okay, this protocol then sending a broadcast to the network. Okay, then the source MAC address, of course, is itself. Okay, then the switch A receives this frame, then we'll know, okay, the host A, this MAC address is connected to this interface. So this information will recorded into the MAC address table. Okay, and then the switch will also decide which interface will this frame forwarding out. Then see the destination MAC address. The destination MAC address is a broadcast. That's all ones. Then this frame will forwarding out all the other interface. We call this method flooding. Okay, we are flooding out all the other interface. So then when the switch flooding out, then host B and host C will receive this frame. And the destination of the layer 2 is all ones. So each host will accept. And then after the layer 2 accept, this packet will forwarding to the upper layer protocol. The upper layer protocol is the ARP. The ARP said he wants to resolve the MAC address of this IP address 10.113. Okay, so the host B seen the IP address needed to resolve is not mine. So the host B just drop this ARP request. But the host C will see that the IP address needed to resolve it's my IP address. So host C will sending out a reply. Okay, sending out a reply. But when sending out a reply, the host C knows from the source MAC address of the request, ARP request. This is the host A requested. Okay, so the host C not sending back a broadcast, sending back a unicast. Okay, unicast. The unicast, the destination of this unicast is the host A's MAC address. Okay, and then the source is the host C's MAC address. Then when this packet sending out, this frame sending out, then switch A received it. Then switch A knows the host C's MAC address is connected to gigabit 003. Okay, so the MAC address table grown. Okay, then there's two items in the MAC address table, and then the destination MAC address of this frame is this address. Then this is unicast. The switch A we are looking up this address into the MAC address table and found that this destination just this MAC address. Okay, so this MAC address is connected to gigabit 001. So this frame only forwarding out to this interface, not forwarding out gigabit 002. Okay, This is difference from the broadcast. The broadcast is flooding out all the other interface, but the unicast will find the destination in the MAC address table and then only forwarding out the certain interface, the corresponding interface. Okay, this is the ARP process. After the ARP process, then host A knows the destination IP's corresponding MAC address. So the host A can encapsulate this. This is the source is .1.1.1 and the destination is .1.1.3. Okay, and then MAC address. The source MAC address just itself AA. Okay, and then the destination just CC. Okay, that this packet can be sending out as a unicast. And the switch A receives this unicast, then finding the destination. Destination is CC, then corresponding to 003. Of course, the source is AA, then refresh this item. Okay, of course, it's the same. Refresh the item, and then forwarding out gigabit 003. Of course, the host C sending out is the same. Okay, this is the process. How the switch forwarding the unicast. Okay, and then this is the basic configuration of the switch. The process of the switch forwarding data and meeting the MAC address, it's work by default. This mechanism is default. We did not need to configure, okay? Not need to configure. But as we know, the Ethernet, the originally Ethernet is the 10 megabps, okay? And then we invented the fast Ethernet. That's the 100 megabps, okay? BPS. And then nowadays, most widely used is the 1 gigabps, okay? 1 gigabps. Of course, there's 10 gigabps and so on. And nowadays, the device connected to the switch. This switch is the speed is adaptable. That means this interface this is a gigabit interface. That means it can running on 1 gigabit BPS. But also, this interface can also running on this speed, 10 mega, 100 mega, also can work. And then another method, as we know, in the coaxial cable and in the hub, the collision will happen. So only one device can send in the data at the same time. So all the device, if it's sending, so there's no other device is sending data, okay? So this mode we called half duplex. Only when itself it's stop sending, then there will be data sending received, okay? This is sending and receiving, not happen at the same time. But now there's a switch and the code. This is a twist pair. Twist pair, there's 8 lines in one Ethernet line. Okay, so there's one pair is for sending and one pair is for receiving. So the host and the switch can sending and receiving the data at the same time. This mode we called 4 duplex. This mode we call half duplex. And this mode we call 4 duplex. Okay, 4 duplex. And then we have 2 parameters needed to configure on the interface. Okay, if this interface is running on which speed, and if this interface is running on which mode, 4 duplex or half duplex. Of course, we can configure it. Okay, based on the NIC type of the host, then we can configure on the switch. But also, we developed another mechanism we called auto negotiation. By default, the switch interface are all enabled the auto negotiation. So the switch will negotiate with the host connected to this interface which speed we should be running and which duplex mode we should run in. Okay, so by default, you did not need to configure the Ethernet interface. Okay, the switch's interface. But if you need to configure it manually, you can configure as this. First, you use the undo negotiate auto to disable the auto negotiation. Okay, then the switch will not negotiate with the host. Okay, and then you specify the duplex mode and the speed manually. Okay, this is a gigabit. That's the 1000 megabps. Then the speed is changed to 100 megabps. That's the fast Ethernet. That's the fast Ethernet speed. And then duplex mode is the 4. Yeah, you can specify manually. Okay, this is the basic configuration of an Ethernet switch interface. Okay. Then after your configuration, you can check it. If your configuration is taking effect, okay, you can use the display interface, then the interface type and interface number, the gigabit Ethernet 001, and then there's many informations, and there's also the speed and the duplex mode. Okay, then also negotiation, auto negotiation is disabled. Okay, the mode of the auto negotiation. Okay, that we got the end of this chapter, and then there are the questions. If a switch records the source MAC address of a host device on a port interface, and the physical connection of this host is then changed to another port interface on that switch, what action will the switch take? That means one host originally connected to one interface of the switch, and then this host disconnect from this interface and then move to another interface, connect to another interface. So first, if this host disconnects to the switch, then the switch interface will be go down. Okay, if the switch interface is go down, then the switch maintains the MAC address table. First, we'll delete all the MAC address learned from this interface, okay, from the MAC address table. And then, if the host move to another interface, then the switch will learn the MAC address from that interface, from that app interface. Of course, only when the host sending out the first frame, then the switch can learn the source MAC address from this interface. Okay, so we have finished this chapter, and thanks for you to join my presentation. Goodbye.